This is a question about a series DC motor, and as we know that series DC motor has its armature and also the series winding that are in series, and we can also connect an external resistance or we can ignore that external resistance, and the current flowing, that is the IT, is actually the current flowing through the series winding is actually the current flowing through the armature. And as it is a motor, so the fundamental equation for the motor will be Vt minus Ia Ra plus R series, and if we have an external resistance, will be like this. So this question, what it is saying is that they have a 220 volt 7 horsepower series motor that is coupled to a fan and is drawing 25 amperes and run at 300 rpm when it is connected to a 220 volts power supply, and no external resistance is connected, so this means there is no resistance connected. Armature circuit, the torque required by the fan is proportional to the square of the speed, and this is true for the series motor. The torque is actually proportional to the square of the speed. So here it is actually Ia square. This is the property for the series motor, and it is given the value of armature and the series winding. We are neglecting all the losses. Determine the power delivered to the fan and the torque developed by the machine. So to find out the power that is delivered to the fan, here is the fan connected. So if we are able to calculate the value of EA and the current being drawn, so we can calculate what will be the power that is being delivered. So EA, if we know that for in series motor is IA Ra plus R series, and the Vt here is 220 volts minus Ia, how much current? 25 amperes it is drawing, and Ra plus R series is 0.6 plus 0.4. So this will become 195 volts. So this is the voltage internally induced. So the power that will be delivered is EA Ia, and that is 195 into 25. So the power will be 4880 watts. Now we know that this is the converted power, and the power converted, we know the formula that it is EA Ia is actually equal to torque induced at the speed. So torque induced, we can calculate EA Ia divided by omega. Now EA Ia is actually converted power, it is equal to this, and omega, they have said that our motor speeds at 300 rpm, and we have to convert this into radians per second, 2 pi over 60. So this will actually give us the value of torque induced, which is 155.2 Newton meters. This will be the induced torque for the series DC motor which is coupled with the fan.